The beauty of physics lies in how wrong we often are. Welcome to Rethinking Physics, the platform to prove you that your first guess is many a times incorrect. And here is today's question. Imagine that there are two cities A and B, and there's a plane flying from A to B at constant velocity and back to A. The next day, it is the same plane, the same cities, and the same trip. But this time, there's a steady wind blowing in one direction all day. So the plane faces a headwind while going one way, and this resists the plane, making it move slower. On the way back, it enjoys a tailwind, making it move faster. Now, the question is, does the round trip take faster on the first day, the second day, or will they be the same? You may take a while to think of an answer. Intuitively, you may think, hey, the headwind slows you down and the tailwind speeds you up, so they should cancel out, right? But well, physics loves to surprise us. Let's do the math. Suppose the plane's airspeed is p, the distance between the cities is d, and the wind speed is w. Let's start with the age-old definition of velocity, which is distance over time. And from this we get time as distance over velocity. And since we have a round trip, the time taken equals the time taken for the forward trip plus the time taken for the backward trip, which is essentially the distance over the forward trip velocity given by v1 plus the distance over the backward trip velocity given by v2. On the first day, we can just replace the distances by d and both velocities by p, and hence we take the time taken to be equal to 2 times d over p. Now let's set this aside and see what happens on the second day. But before that, let's see how the plane's net velocity is affected by wind. During the forward trip, the wind resists the motion and the net velocity of the plane is going to be p minus w. This is because for every second, the plane propels itself by p units, but is brought back by w units because of the wind. But on the backward trip, the wind is going to assist the motion and the net velocity becomes p plus w. This is because the plane propels itself by p units each second and further by w units because of the wind. Replacing v1 and v2 by these new velocities, and with the help of some simple math, we arrive at t equals 2 times d times p over p squared minus w squared. Now let's compare both cases. For that, we can just assume the time taken in both cases to be equal and reverse engineer the conditions under which this occurs. The constant 2 and the distances cancel each other out, giving us this equation. After some cross multiplication, we get p squared minus w squared equals p squared, which goes on to show that w squared equals 0 and w equals 0. In other words, the time taken would be the same only if the wind speed is 0, which technically means that it is not the case when you know that there's a non-zero wind on the second day. Now that we know both of them are equal, which one takes more time? For now, let's assume that it is day 1. Again, after cross multiplication and cancelling out the p squared on both sides, we get negative of w squared is greater than 0, or w squared is less than 0, which is never the case, unless it comes to some imaginary numbers, which is a story for another day. And this goes on to say that the plane takes longer on the second day than on the first day. And from this we can conclude that a headwind doesn't just slow you down, it slows you down more than a tailwind can ever speed you up. The penalty for being slow is worse than the reward for being fast. This could have been intuitive if we thought about some extreme cases, such as what if the wind speed was equal to the plane speed, in which case the trip taken in one direction had taken half the time as the plane travels with twice the speed, but in the other direction the plane virtually never moves at all and takes an infinite time to reach the other city. And worse, if the velocity is over p, the plane will drift away from the city even if it attempts to move towards it. Did your intuition fail you this time? Let us know. And when in doubt, it is time to do the math and rethink physics.